Alright, let's look at the trig integrals. Alright, so first six of them are just a reversal of the derivative. So if you look at these, let's say here, no, first one, derivative of cosine of, or negative cosine of x is positive sine of x, right? So it's just a reversal of that. So integral of sine of x is negative cosine. Right? Derivative of sine is cosine. So if you take the antiderivative of cosine of x, you get sine of x. Right? So this is just a reversal, and this is also reversal. Right? And here, derivative of tangent is secant squared. Derivative of cotangent is negative, but there's a negative sign, positive cosecant squared. So those are just a reversal of the derivatives. Right? Derivative of sine is a derivative of secant is a secant tangent. Derivative of cosecant or negative cosecant is cosecant cotangent. Alright, so first six of these are just a reverse version of the derivative process. Right? But I guess we need to give a little bit more explanation for the last four. Right? So I'm going to look at the tangent one. Right? So this is tangent works this way. Right? If you want to find the antiderivative of tangent, right? So what you can do is we can use the tangent definition of tangent. Tangent is sine of x over cosine of x dx, right? Then we can use this trick again. Remember that if you're taking the antiderivative of g prime of x over g of x, then this is going to be natural log of absolute value of g of x plus some constant c, right? And if you think of cosine of x as our g of x, derivative, so g prime would be negative sign. So what you can do is, I would like to have a negative sign, so I'm going to put a negative sign here and put the negative sign outside, right? That way, we have negative sine of x is exactly the same thing as g prime of x, right? So using that trick, it's going to be, don't forget the negative sign, it's going to be negative natural log of absolute value of cosine of x plus c, right? So that's where this guy comes from, right? So we got that. And the cotangent is very similar, so I'm going to skip the proof, but you can just do the, write cotangent as cosine of x over sine of x, and then go from there. All right. How about the last two? Right. I can do either one, but I'll probably do a secant one. All right. So if you want to find the antiderivative of secant of x with respect to x, all right. So what you can do is we're gonna do this. This is a kind of a strange trick, but we multiply top and bottom by secant of x plus tangent of x, right? Since we don't want to change the quantity, we're going to have to do the same thing to the bottom. So you do that, right? And here, this is how it works out. So this is going to be, right? So the denominator is secant of x plus tangent of x, right? And derivative, remember that the derivative of secant is secant tangent, and we actually have that secant of x times tangent of x, right? So if you distribute that to tangent, you have secant of x tangent of x, right? Plus, right? If you distribute secant of x to secant of x, so you get secant squared. So you have a secant squared of x, right, dx, right? Then we're going to do exactly the same trick. Remember the derivative secant and secant tangent, derivative tangent and secant squared? So we take this as our g of x, and we got really lucky here. This guy is exactly g prime of x, right? So this is going to give us natural log of absolute value of secant of x plus tangent of x plus some constant c, right? Where that's come from, right? You can prove these two. So this one very similar to the first one, and the last one is very similar to the last one, right? So I'm gonna skip those, but you should be able to easily prove those two. All right, that's it. I hope that this was clear.